Okay, this was an assignment I wrote today, but this was incorrect. Once again, this assignment was incorrect. I'm deleting it, and it should have been page 19 through 21. I'm uploading right now, trying to put it on YouTube. So, again, we started this. This is community pool prepared for opening day. The graph shows the depth of water in the swimming pool after X hours. So, why do you think the pool was emptied and then refilled? You can put anything you want here, any reason you like why it was emptied. You can put that the water's dirty, they want to start over, so they're emptying the pool. So, any reason. Refilling for a special day, because they're emptying it to refill for a special day. That's what I'm going to put. Refill to put in new water for a special day, for a party, whatever the case may be. Why is it emptied and refilled? So here's the pool. It's full. They're emptying it. It's empty down here, and they're refilling it up there. Okay? Just if you don't understand, it's explaining it to you. Complete the table. Okay, before you complete the table, you need to label these by intervals. This, if you can see, that will be the A part. Okay? Before it goes down, that is your A. And then it goes down here, right here, that is your B. Okay, it goes down some more, and they empty it all the way really fast. That is your C, and then it stayed empty for 4 hours. Okay, stayed empty for 4 hours, and that's your D. And then they fill it back up real fast. You see how steep that slope is? They fill it up real fast. That is your F. Okay? So at least there's only 1, 2, 3, 4, 5. Your other assignment wants forever. Okay, the time interval for A is from 0 to 2. Here's A. A is 0 to 2. That's the time interval. Right there. 0 to 2. Okay, then B, the time interval for B, I will use green so you can see the difference. It's 2 to 6, right there. 2 to 6. 2 to 6. And the next one is red. From here, it's 6 to 8, right there. 6 to 8. 8 hours. And I need to check something to see if your thing is 84 degrees. That's your other homework. Wanted to see if it was done uploading. Anyways, it takes a long time. D is from 8 to 14 hours. D is 8 to 14. Probably 8 to 2 in clock time, but we're just going to use the numbers here. 8 to 2 or 8 to 14, and then 14 to 18, or the very end here, 20. Oh, actually we only go up to, we feel the water, I'm assuming up to here only. So 14 to 18, right there to 19, because we want to fill up back to 7 feet. That's the original depth. So 14 to 19 hours. Okay. Okay. So let's go. 0 to 2 hours. 0, I'm going to erase all this because it's quite a mess. I was just teaching you. to see it. Now, 0 to 2 hours is A. Okay. The pool is still 7 feet. They haven't emptied it. Okay. Pool is still 7 feet. Have not emptied the pool for the first 2 hours. Okay? So right there, it's a horizontal. The rate of change is 0. Rate of change, that means the slope is 0. So it's a horizontal line. 2 to 6. 2 to 6, the slope is going down. They're draining the pool from 7 feet to 5 feet. They are draining the pool from 7 feet to 5 feet. Okay, that's 2 feet. I'm going to check my graph just to make sure. 5 to 7. 2 feet in 4 hours. So 2 feet in 4 hours. It drained 2 feet in 4 hours. That means it drained a half a feet or 6 inches, half a feet, 6 inches in 1 hour. 6 inches, instead of in 1 hour says per hour. That's a rate of change word. Okay, the rate of change is 1/2 feet per hour, or 6 inches per hour. Now 6 to 8, they drained really fast. It went from 5 to 0. 6 to 8 went from 5 to 0. The pool drained from 5 feet. Well, this is a negative half of a feet. So, because it went down. Well, measurement is never positive or negative. So, leave it positive. The pool drained from 5 feet to 0 feet in 2 hours. So the rate of change is 5 divided by 2, which is 2.5 feet. 2.5 feet per hour. Okay? Now, from 8 to 12 hours, right here, we don't know the time though. Sorry, 8 to 14 hours, the line is horizontal, there's no change. From 8 to 14 hours, the pool remains empty. The pool, let's not write this. From these hours, the pool had no water. And it didn't change any. The rate of change is 0. Now, from 14 to 19, when it's all filled up again, or in this case, yeah, about 19. From 14 to 18, the pool increased. They filled it up. It looks like the rate of change is the same. 1 hour, they put in 1.5 feet each. 1.5. So every hour they filled the pool at 1.5 feet. So at every hour so it went from 14, let's just 14 to 19. Okay, 14 to 19 hours, that's 5 hours. 0 to 7 feet. Not quite set. Not quite 19, almost. Let me look at. Where is it at 7 exactly? It's not the exact hours. So they filled up the pool between 18 and 19 hours. That's what we would put. Pool was being filled at a rate of 1.5 feet per hour until it got full at 7 feet between 18 and 19 hours. Okay? Was the pool emptied at the same rate the entire time? No. The pool was not empty at the same rate. Was not empty at the same rate. The pool first was drained at a rate of 0.5 feet per hour between 2 and 6, and then it went to 2.5 feet between 6 and 8. So from 2 to 6 hours, it was drained at 0.5 feet per hour. Where at 6 to 8, the pool was drained at 2.5 feet per hour. And you get that answer by looking at your chart. Also, why does it make sense to graph the situation be continuous rather than discrete? Okay, why does it make sense for the graph in this situation to be continuous rather than discrete? Because the pool is being emptied every single second, continuously. When they start emptying the pool, it was continuous. When they stop, it was a continuous period. That's why it is a continuous graph. You can't put a drop of water and then stop. It just doesn't make sense. Anyways. Continuous because the pool was emptied at a constant rate. That means the slope is the same. At a constant rate, continuously. There's points where you leave it at a long period of time empty, and filled at a constant rate also. And filled at a constant rate. So when the rate of change is the same, filling and draining,